Hey everyone, how are you? Alright, so I think the stream has started and now we can start solving today's lead code problem of the day. Alright, the question is count the number of maximum bitwise OR subsets. That is what this is the question which we are going to solve today. That's a problem of the day for lead code today, and this is of medium level. I see this the question is of medium level. All right, in this question the given input is an array of integer nums, and the output we need to give is the number of subsets of the given array of integer nums whose bitwise OR is equal to the maximum bitwise OR of nums. Alright, so I see the question is about finding the number of subsets, right? We need to find the number of subsets from a given integer array nums, and those subsets are valid for which the bitwise OR is equal to the maximum bitwise OR of the given array nums. I mean, let us start first reading the question. Let's go through the question a bit. Let me switch to the browser. Alright, so if I just go through the question and try to understand the question. So we are given an integer array nums. We need to find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. Right, and what is a subset? And let me try to explain you what is a subset with the drawing pad. For example, if there is an array 1, 2, 4, you can call another array a subset of this array when you can select elements from this array in the same order in which they are in the original array. For example, I can select 1 and 3 and I can say 1 comma 3 is a subset of 1 2 3 4. I may select from the given array 1 2 3 4. I may select 1 2 and 4. 1 comma 2 comma 4 is also a subset, but I cannot say 3 comma 2 is a subset because although I think we can call 3 comma 2 a subset. I am misconfusing this with one very important concept called as subsequence, right? So it is about subset, right? So the order doesn't matter in a set. All right, I think, yeah, now we get it. If we are given an array, let us select any elements from the array and we can call it as a subset, right? What I was about to tell was subsequence, so I would say let's go for the subset. Alright, so I see people are here, people have joined. Khan Singh, he's a regular viewer, is joined for joining the stream, and I think thank you for being with me. Let's continue and solve the question. So I am talking about the subset, right? So from a given array, let's say this the array is 3 comma 2 comma 1 comma 5. You can select any element and call it as subset, right? The thing is, you cannot select the same set of elements two times. For example, if I selected 315, I cannot say 513 is another subset. So 315 is a subset, 513 is a subset, but they are both the same subset because they are made with same elements. Alright, now let's try to understand the problem a bit with the given example. See, the thing is, we are given an integer array, right? Using this integer array, what we need to do is we need to find what are the number of subsets, right? What are the number of subsets whose bitwise OR is equal to the maximum bitwise OR of nums. So the thing is, we need to find those subsets whose bitwise OR is equal to the maximum bitwise OR of nums. So from here we can understand that we first need to find out what's the maximum bitwise OR of our given original array nums, right? Our original array nums is 3 comma 2 comma 1 comma 5. So what is the maximum bitwise OR of this particular array? Now the thing is, for a given array, if you want to find out the maximum bitwise OR, you need to take the bitwise OR of each element. That is 3 bitwise OR 2, bitwise OR 1, bitwise OR 5. That's the that's the bitwise OR of all the elements, right? Now what is the maximum bitwise OR possible for a given array? It's basically taking the bitwise OR of each element, and I will tell you why. Now there can be a doubt, there can be a question that why should I, why should I take each element and take the bitwise OR and then call it as the maximum bitwise OR of our given array nums, right? The thing is, bitwise OR is a progressive operation. And what do we mean by progressive? It means that if you take the bitwise OR of A and B and you get the value as C. Now, if you take the bitwise OR of C with some other number D and the output is E, let us say the output is E, then this E is never going to be less than the C. You can take any number D and take the bitwise OR of C with D. This is not going to decrease. For example, if we talk about two numbers 3 and 2, right? So the bitwise OR of 3 and 2, this is actually equal to 3, right? Now if I take the bitwise OR of 3 with some other number, let us say the number is x, then this output will never be less than 3. It can be 3 or more than 3, and that is why I am saying the bitwise OR is a progressive operation. Whenever you do bitwise OR of multiple elements, your output is always going to increase and never going to decrease, and that is a mathematical property. There is no thought process, there is no intuition behind it. It's a normal mathematical property, right? If I say 3 plus 2, this is a normal addition operation, this is equal to 5, right? Now if I add any positive number to 5, this is always going to be more than 5, right? The output is going to be more than 5. The same goes for the bitwise OR case. If you want to take the bitwise OR of two numbers, right, and with the output you want to take the bitwise OR of another number, this is always going to be more. It will never decrease. So when we talk about our original array and the output we need to achieve, this will be the number of subsets, right? We need to find the number of subsets, but before counting those subsets which we need to find, we need to understand that we need to find the maximum bitwise OR of our nums array, and that is because only those subsets will be counted whose bitwise OR is equal to the maximum bitwise OR of nums. And see how we can find the maximum bitwise OR. Just take the bitwise OR of each element, right? So our elements are 3, 2, 1, 5, and the bits, when we say bitwise OR, you need to convert your number into bits or binaries, I would say. For 3, the binaries are 0, 1, 1. 2 into binary will be 0, 1, 0. 1 will be 0, 0, 1, and 5 will be 1, 0, 1, right? Now to take the bitwise OR, you can say that this will be 1 when any of the element is 1, right? I mean, it is a very simple addition, a bitwise OR operation. So I'm not going to explain a lot because I think you guys are smart enough to know this. But yes, if you have any doubt, any questions for this, you can put it in the comment box, put it in the chat. Thank you V2 Music Box for joining this stream. Now let's do the addition. All right, this will be 1, this will be 1, and this will be 1, and the bitwise OR operation has produced the output as 111, which is actually the number 7, right? For the number 7, this is the binary, right? So the bitwise OR operation can produce a maximum value of 7. Now the thing is, what we need to achieve is we need to find all those subsets from this given array, all those subsets whose bitwise OR can produce the value as 7, right? Now let's focus on finding that value, finding those number of subsets. Now here are two things. First is, how can you find all the subsets for your given array? because if I just go back to the question again, you will notice that now in the question we are given the length of our array nums can be up to 16. It is never going to be more than 16, right? So the given array nums will be of length 16, and if we want to find out, let us say we are given a length 16 array, right? That's our input. Now at this point, if I try to find out what are the number of subset I have, like total number of subset without any condition, then it will be 2 is to power 16, and this 16 means that the length of my array. And this is again a basic formula. To find the number of subsets, it will be 2 is to power n. N is the number of elements in your array. Now we can find all these 2 is to power 16, I would say 2 is to power 16 subsets, and for each of the subset we need to find, is this subset having the bitwise or equal to 7 or not, right? All right, we are going to proceed for that point, but before this, let's proceed and code the part where we can find the maximum bitwise or of our given array nums. For this, let's go back to our code editor. In the code editor, what we need to do is we need to first find out what's the actual maximum bitwise or for my given array nums. And for this, I can say, let's say mx is equal to 0, right? Now, for each of my number in nums, I can say mx will be equal to mx then bitwise or with the current number nums or the current number n. Now this mx is going to store the maximum bitwise or which is possible for my given array nums, right? So that's the first point. Now let's again go back to the pad and let's try to understand more about how we can solve this particular problem. All right, now first of all we need to create all the subsets, and I will tell you the reason. I will tell you the intuition behind this. The thing is, we need to count the subsets, and each subset is a unique subset, right? So we need to go through all the subsets and see that which subset is having the bitwise sum or bitwise or is 7, and that will be counted. A very simple method for this is always something called as backtracking. Again, if I talk about the intuition behind this, it is very simple. You want to find the number of subsets, right? The intuition is always going to be to find all the subsets. The thing is, if you can find one subset, and from you using the one subset, if you can find the answer for the second subset, that's one thing, right? You don't need to produce the second subset. Using the first, you can find the answer for the second. That is going to be a more optimal solution. But one of the process can be just try to find all the subset. Let us try to solve it by trying to find all the subset. If there is any optimization required, we are going to do it, but first of all we need to try to find the all the subsets. And to find all the subsets, one of the best method is always backtracking. Again, talking about the intuition, you just need to remember to find all the subsets. Backtracking or recursion is one of the best way. All right, now how can we backtrack, or how can we find all the subsets? Now, first of all, what we need to do is, first let's write all the subsets which are possible, right? There are 4 elements, so we can have 2 is to power 4, which is 16 number of subsets, right? These are all the number of subsets which are possible. Now to find all the subsets, what we can do is we can start with an empty array, right? As of now, I don't have any data. As of now, I am not as of now I am not seen any element. Now what I can do is, now let us see about the first element. Let us see the first element, which is 3. Now our first element is 3, right? Using the 3, I can create two subsets from an empty array or an empty data. I can create two subsets using 3. That's the first element, right? Now imagine the situation here. I get to see one element. At this point, I don't know about other elements. How many subsets are you going to have? It is 2 is to power 1. As of now, we have seen one element, so 2 is to power 1. All right. I think Yeah, thank you, Shubham, for joining the stream, and thank you for your awesome words. All right, let's get back to solving the question now. As of now, we have seen one element which is 3. I have an empty data. How can I find all the subsets with 3? A very simple way is just do two operations. What I can do is I can put 3 into this, or I may skip putting 3 into the empty data. If I put a 3 into the empty data, it will be 3. If I don't put any data into the empty data, it will be empty. It will be still empty, right? But you will see that we got two data here. Both these data are the subsets of 3. This is an empty one, this is a non-empty one. Now again, if I just see the next data, which is 2, right? I see the next data, which is 2, and now what I can do is I can again try to create more subsets, because as of now I have seen two data, which is 3 and 2. So the number of subsets are going to increase, right? It is going to be 2 is to power 2, which is 4. I have to create 4 subsets. I have created first, then second. Now let us create the third and fourth. How can you do it? We need to perform the same operation to perform. And what are those operations? I just need to put this 2 into my existing data, right? If I put this 2 into my existing data, it will be 3 comma 2, and if I put it into the empty one, it is going to be 2, right? So now I have seen 4. This is the third and this is the fourth. I have seen a total of 4 subsets, right? Those subsets are the empty. We started with an empty data and we put this 3 into our empty data, right? Now, as of now, this might look a little bit ugly, so let me make it a bit beautiful. What I can do is I can say I started with an empty data. The first data I see is 3, so I added a 3, and now I have a 3 here and the empty data itself, right? Now I see the next element is 2. I added a 2 into my existing data, so it will be it will be 3 comma 2, and then for the second data, which is an empty, if I add 2 into this, it will be just 2, right? Also I need to include my existing elements, which are 3 and empty data. So my existing elements are 3 and empty data, right? So now I have 4 subsets of my elements 3 comma 2, and that's exactly what we need to do. We need to start with an empty data, and we need to perform two operations. Either we can add our new data into the empty data, or we may skip adding. If we add it, we will get one subset. If we skip it, we will get one more subset. And similarly, these are the two data I have. Now if I add this 2 into my existing data, which is and a set is 3, if I add it, now I will get another set, which is 3 comma 2. If I don't add it, I will get the same element, which is 3 itself, right? And similarly with the second element, if I add, I will get one subset. If I don't add, I will get the original one. Now the thing is, we need to find the bitwise or as well. Apart from adding it, we need to find the bitwise or. So now our logic can be, let us start with the first element. Let us start with this particular 3. As of now, I have got my bitwise or can be 0, and I have not seen any of the element, right? Now the next element I see is 3. What I can do is I can add this 3 as a bitwise, or I can perform this bitwise, or I can say, okay, one of the subset bitwise or is going to be 3, another subset bitwise, or I can say let me not add 3, and this will be 0. Now the next element I see is 2. Now what I can do is I can just perform the same operation, but instead of adding my elements into the list, I can keep performing, I would say I can keep performing the bitwise or operation, right? So let me take this 2 and perform the bitwise or with 3. This will be the 3 and bitwise or with 2 will be 3 itself, 3 again. So it will be 3. But if I do not perform the bitwise or of 2 with 3, I will get another subset, and that subset will have the bitwise or as 3 itself, right? So I had a subset. If I perform this bitwise OR with 2, I will get another subset which has the bitwise OR as 3 only. I have a subset with which if I don't perform the bitwise OR, then I'll get the same subset back, which will have the bitwise OR for that particular subset as 3 only. And that is what we are doing. That is the recursion part. That is the backtracking part we are doing. For we are just we will keep adding element into our set, but instead of creating the set, our set will be nothing but the bitwise OR, right? Now let me try to go back to the browser and let me try to show you how we can solve this. So what we can do is, let me think about this. First thing what we can do is, we can create a function. Let's create a function, and let's no let's put a name to the function. Let's put the name as check. All right, we are checking that if a subset is, a created subset is having a bitwise or equal to mx or not, right? All right, it is going to accept two arguments, the index and the current sum. I would say the current bitwise or, and why the index I'll tell you, and why the current sum, both I will tell you. See, the thing is, we need to call this check with my current index 0 and current sum as 0. What we are trying to achieve is, if my input is 3215, I will have this first element added into a set, or and I will call this as a subset. That is, as of now I have an empty data. I will add my 0th index element, which is nothing but 3, and I will perform the second operation as well, in which I will not add this 3, right? This is how we create the subsets. If I don't add a 3, I will get 0, right? For the first subset, the bitwise OR is 3. For the second subset, the bitwise OR is 0. That is what we are trying to achieve. So this is the index with which we are going to start, and this is the sum or the bitwise OR of my empty data as of now. So now what we can do is, our first check should be, that this index should never, this index should never exceed uh, the length of my array, right? That should be one of the check, that if the length of my the length of my nums array, if it is equal to, if it is anytime equal to, I would say equal to idx, right? At that point, what I can do is, what we should do is, we should we should return back. Let's return back, okay? Else, if we are having an index which is less than the nums, we can perform some operations. And what's the operation we need to perform? That is something we need to understand, right? See, the thing is, we need to again check, we need to check with the next element, right? But before moving to the next element, we should perform two operations. We should add 3 in one of the subset, and we should not add 3 in one of the subset. Our first subset is an empty data, right? So what we can do is, we can call the check function again, right? We can call the check function again, and that is what, let me put a pass in the else as of now. We need to call the check function again. In the check function, we need to call with the next index, that is my next element. And for the first subset, with my current sum, what I can do is, I can take the bitwise OR with my current sum and the current element, which is nums of idx, right? And what more I can do is, I can say check again, and again with the next element, that is, let us say here it will be the index number 1, which is 2. But this time I will pass my current sum only. That is, if I start with 0, don't include 3 and pass it along. Now at this point, I think we are good. Now the next thing what I can think of is, let me analyze this. What we should do here is, we should first deal with this condition, that the moment I get that I am at my last index, at that moment I can say, if mx is equal to cs, then let's return something, else let's not return something. Okay, what we are trying to do is, we are trying to count, right? We are trying to count, and if we are trying to count, the moment we get that if my current index is the index which is equal to the length of my nums array, it means we are having a subset which is having the complete array 3 comma 2 comma 1 comma 5. And now we are, or let us say we are having a subset, and now we are trying to add an element which is outside of this range. So at this point I have a subset, we are coming with a subset whose bitwise sum is CS. And at this point I'm checking that if the index is more, I don't need to go to this condition, that is I don't need to backtrack again. Now if I don't need to backtrack again, at this point what I can do is I can say let me return 1 for this, because if I'm getting mx equal to cs, it means that I got one number of subset whose sum is equal to the maximum bitwise or for my nums array. Else I can say return 0, right? That's the base condition, I would say. The moment we are at the extreme end of our number of elements, let's end the loop, and before ending the loop let's return the count. So what we can basically say is, for both the checks, let me add both the checks. That is, if I just add both the checks, let me put it in the same line, because we need to count the number of subsets, right? So let me add this. If I add both the subsets count, this will count the subset, this will count all the subsets whose maximum whose maximum, I would say, bitwise or is equal to the bitwise or the maximum bitwise or of my given array nums. All right, now what if instead of putting it as else, let's put it as elif. What if with the current sum is actually equal to mx. At this point, if my current sum is actually equal to mx, that is, if we are coming up with an index which is not my extreme index, not an index out of the range, but my current sum is right now equal to the mx, which is the sum we are looking for. If that condition is true, then what should we do? We should actually do the counting, right? Now at this point let me do one thing. Let me let me go back to the tab. Let me try to explain you a very important concept. Now let us say your current array is, let us say your current array is 3215, right? So let me put it like this. If your current array is 3 5 1 2, right? If you're creating subsets and you created a subset like 3, the first subset you created is 3, then the next subset you created is 3 comma 5, right? For 3 comma 5 you will notice that for 3 the bitwise or is 1 1, for 5 the bitwise or is 1 0 1, right? When you will sum it, it will be 1 1 1, which is actually equal to 7, right? Now the moment you are getting a sum as 7 for 3 comma 5, any subset which you will create with ongoing elements who has the sum as 7, for that is what I am trying to say is, if you are coming up with 3 comma 5, that's your current subset whose I would say whose bitwise or is 7, right? Now if you try to include the or try to create a subset by adding 1 into this, or try to create a subset by adding 2 into this, all these subsets are definitely going to have the bitwise or equal to 7, right? I don't need to count it, and the reason I don't need to count it is, if I add 1 into this, the bitwise or will be 0 1 1 1 0 1 and then 0 0 1. This will again be equal to 1 1 1, right? Your bitwise or will never be more than 7, because 7 is the max, right? So if I have a subset whose bitwise or is 7, in this subset if I try to add elements, then all the elements which are getting added and creating new subsets are going to have bitwise or equal to 7, right? So for those elements, for those subsets, I don't need to recount, and that's what we are trying to achieve here. What we are doing is, let me go back to the browser again. At this condition what we are saying is, we are at an index which is not the extreme, that is we still have some elements to see, but we got a sum cs which is equal to mx. At this point, how am I going to count it? Should I count it as 1? I mean, should I say return 1, that is not going to be a good solution. And the reason is, if we just return 1 and then again go, continue the continue the search for other subsets, it is not the most optimized way to do it. What we can do is we can actually find the length of the number of elements we are left with. We can say the length will be len of nums minus my current index. That is, if we are let me again go back to the tab, because this might be confusing. That is, if I have 3 comma 5, right, this has given me a subset which whose sum is 7, right, whose bitwise or is 7. Now I got a element 1, I got a element 2 to see. So I got two more elements to see. It means I can create 2 is to power 4, not 2 is to power 4, sorry for that. We can create 2 is to power 2. These number of more subsets, right? Apart from this, we can create these number of more subsets. So I need to count all these subsets. For all these subsets, the sum will be 7, or the sum will be maximum. So this is the length. Now after finding the length, what we can say is, don't return 1, instead of that return the power of 2 comma length. These are the number of subsets which we have got if the current sum is equal to the max sum. And this is the value we need to return, right? We don't need to just call it, we need to return it back to my original check function. This is the function, this is the place where we are actually calling our check function. We need to return this value, right? Now after returning this is the function which is returning the value. After the function has returned the value, return the output, that is, it has checked for all the subsets whether it is a subset whose bitwise or is equal to the max or not. I got the count because right now I'm doing the counting. I'm trying to search for a subset by including this current num and not including the current num and going for the next index. So it is a very classical way of backtracking and finding the, I would say it is a very classical way of backtracking and finding this all the subsets. Now I can return back the value. Once I return this is going to pass all the test cases, but if it doesn't, then we are going to tackle it. So if I just run this, all right, it's taking some time. Fine, maybe we have, I think we are good, it is accepted. Now let me submit this. This should pass all the test cases, right? I have solved questions like this, so confidently I can say that this should pass all the test cases. And let's wait for the output. All right, meanwhile I'm waiting for the output. You guys can comment your thoughts, like, should I continue live and should I explain the questions live, or should I do the way I used to do, that is create the videos offline and then edit and upload it. Obviously when I upload it back in a fast forward manner, so that you are only focused to understand the solution and it takes a less amount of time. But the reason I switched to live streaming and trying to explain you live was, let's have some more interactivity. We could interact more. If you have some more questions or some more doubts or some more things which you want to ask or suggest, we can do that, right? All right, let me see. All right, I think we have solved the question, right? The runtime is good, the memory used is really good. I would say the memory used is really good. Even though it is 55%, it is good. So I think we have solved this particular problem, and it was a very simple problem, guys. Yes, it was medium level, but I would say it is justified to be medium if you don't know about finding all the subsets. But if you know how can you find all the subsets, then it is actually a very easy problem. What we did is we just found out what's the maximum bitwise or possible for nums, then a simple check for all the subsets possible. We started with the first index. I mean, the first index is always the index number 0 and the current sum is 0. Then we continued our search for each of the next indexes, right? And whenever we are searching for the next index, we are doing two operations. Either we are adding this element in our current subset, or we are not adding it, right? We are doing both the operations, and once done, this is going to solve our problem. All right, I think we are good for this stream, guys. If you have any questions, if you have any thought process, maybe we can discuss, or else think I'm good. Next stream in the next video, I'll wait for some time. If I get some response, great. Otherwise, I think we are good to close this stream. Also, if you are watching the stream, then make sure that you are hitting that like button, because I mean, if you are liking it, but if you are having any questions, you can put it in the chat box. And I would say, from the efforts perspective, it takes a good amount of efforts to create videos, I would say. But going live and explaining live is a whole different thing, right? When you are doing it offline, it's easy as compared to going live, because you don't know what are the words you need to put to explain something. You have to do it live, right? So that's the thing. I think we are good, guys. We are good to close the stream. We have solved the particular problem. So I will see you guys in the next stream. Thank you for watching this stream. Thank you for being with me in this stream. Thank you for putting some really good messages, Shrikant, to Music Box, and Shubham Kumar, obviously. So thank you again. I'll see you guys in the next stream.